Imagine a plant that's been feeding us for, like, tens of thousands of years. Maybe even paved the way for rice paddies. But most people barely know it exists outside certain cultures.
That's taro in a nutshell.
Exactly. Welcome to the deep dive.
Today we're really digging into Colocasia esculenta. That's taro. We've got these sources, and our job is to pull out the key stuff, the really important bits about this amazing but, yeah, often overlooked crop.
We'll look at where it came from, way back when, how incredibly versatile it is, touch on, how to actually grow the stuff.
And try to figure out why. Why something with so much potential is still kind of under the radar globally.
Yeah, that's the paradox, isn't it? How can something so ancient, so packed with nutrition, so adaptable?
Right, how can it be undervalued? Or even, called a weed in some places.
It's fascinating. We'll definitely explore that.
It's a real puzzle we'll try to piece together today.
Okay, so let's start simple. What is taro, fundamentally?
Well, it's a plant, a herbaceous perennial, meaning it comes back year after year. Most people probably recognize the leaves.
Oh, the elephant ear ones, big, heart-shaped.
Exactly, huge leaves. You might also hear names like Edo or Dasheen. Depends where you are.
And the part we eat, it's not quite a potato, is it?
No, not exactly. It's technically a corm, which is basically a swollen underground plant stem. Think of it like a base where roots grow from, usually got these papery skins on it, different from a true root or a tuber.
Got it. A corm. And you mentioned ancient. Just how ancient are we talking?
We're talking really ancient. It's one of the oldest cultivated crops, period, native to Southeast Asia, we think.
And there's proof.
Oh, yeah. Archaeological evidence. Kilu Cave, Solomon Islands, that pushes it back maybe 28,000, even 20,000 years ago.
Wow. 28,000.
It's incredible, isn't it? Then there's Ili Cave in the Philippines, at least 11,000 years. Coke Swamp, New Guinea, 250 BC.
So this wasn't just one group finding it.
Seems unlikely. It spread across the Pacific into other tropical areas. It really suggests people domesticated it in different places independently. It shows how vital it must have been.
And not just vital back then.
Yeah.
Nutritionally, it sounds pretty impressive today, too.
It really is. Packed with carbohydrates naturally, lots of dietary fiber, good source of vitamin C, potassium.
And you mentioned protein.
Yeah, surprisingly high protein compared to a lot of other root crops. That's a definite plus. We often think of potatoes, right? But taro, it holds its own, maybe even edges them out in some areas.
And you can cook it lots of ways.
Oh, absolutely. But only cooked? That's key. You can boil it, bake it, steam it, fry it. People process it into puddings, breads. Polynesian poi is probably the most famous.
Right, poi.
And it's not just the corm. The leaves, the stems they get used to, like in Hawaiian laulau.
So nothing goes to waste.
Pretty much. Modern uses too, flour, chips, patties. It's genuinely a zero waste kind of plant. Leaves, peel, corm, all usable.
Historically a lifesaver in famines, I bet.
Absolutely. And it carries huge cultural, even spiritual weight in many societies.
Okay, but you mentioned cooking it as key. Let's circle back to that. Safety first.
Yes, definitely. This is super important for anyone listening. Raw taro the corm, leaves, stems, all of it contains these things called calcium oxalate crystals. They're acrid, sharp.
Sounds nasty.
It is. If you eat it raw, it causes severe irritation. Your mouth, your throat. It's really unpleasant, even dangerous.
So just to be crystal clear.
Yeah.
You must cook taro thoroughly.
Imperative. Cooking or fermentation breaks down those crystals. No shortcuts.
And even just handling it.
Yeah, wear gloves. The sap can irritate your skin too. Not as bad as eating it raw, but still, best to be careful.
Right. Safety message received. Cook it well, handle with care.
Exactly.
Okay, so let's say you're intrigued. Maybe you want to try growing it. What's the ideal setup, the environment?
Well, think warm and humid. That's taro's happy place. Best temps are around 25 to 30 Celsius. Well, it's at 77 to 86 Fahrenheit.
Okay.
It can handle hotter, up to maybe 38 C, but the key thing is it hates the cold. Below 20 C, growth slows way down. Frost, forget it. It's really detrimental.
So you need a long, warm season. Or at least 200 frost-free days.
Yeah, minimum. And water, lots of it. Consistent rain is ideal, like 250 centimeters a year spread out.
And if you don't get that?
Irrigation. You absolutely need irrigation. Misting can help too if it's dry.
What about the soil? Picky.
It's pretty adaptable, actually. But for the best results, you want deep, loose, loamy soil. Well-drained, of course, and rich in organic matter.
And pH.
Slightly acidic to neutral is good. Around 5.5 to 6.5 is perfect. Definitely avoid rocky soil. It messes up the corms.
Okay. Sun. Does it need full blast all day?
It can take full sun, but it also does fine in partial shade. In really hot places, that afternoon fade is actually a benefit, stops it getting stressed.
Makes it good for planting under other things.
Yeah, excellent for understory planting. But going back to water for a second, this is important.
Right.
It needs a lot of water, right?
Huh.
Tolerates wet feet, even. But stagnant water, that's a killer.
So standing water is bad.
Exactly. Stagnant, oxygen-poor water leads to root rot, all sorts of problems. It needs moisture, but the water needs to be able to move, or the soil needs to drain well.
So those traditional wetland paddies, the water's flowing through them.
Precisely. That keeps it aerated. If you're growing upland or in a container, it just means consistently moist soil, but soil that drains well. Active management, not just flooding it.
Got it. It's a nuance, but a crucial one.
It really is. Makes all the difference.
So how do you start new plants, seeds?
Mostly no. It's usually vegetative. You use headsets, that's the top bit of the corm with the leaf stalks still attached. Or you can use large suckers that grow off the main plant.
Okay.
Although these days, tissue culture is becoming really common. You get these little plantlets grown in a lab.
Advantages.
Big ones. They're guaranteed disease-free. They grow uniformly. And generally, you get higher yields. It's a more modern approach.
But if you're using headsets or suckers, preparation sounds important.
Absolutely critical. You want material from healthy, strong plants, clean it up really well, take off any bad bits, dead leaves, old roots.
And
then this is the really crucial step. You let it air dry for at least 2 days.
air dry.
It's called healing or curing. It lets the cut surfaces seal over. That stops pathogens, fungi and bacteria from getting in when you plant it. Super important step. Sometimes people treat with fungicide too, or trim leaves if there's leaf spot around.
Right. Let it heal. Makes sense. Okay, so it's prepped, getting it in the ground.
Yeah.
How do you prepare the field?
Pretty standard. Like for other dryland crops, you work in the existing vegetation, add lots of compost or manure, mix it in deep, maybe 20, 30 centimeters. Let the soil settle a bit, then break up any big clods, make it nice and smooth. If your soil is heavy clay, building raised beds is a really good idea. Helps with that drainage we talked about.
Good tip. What about timing? When do you plant?
Depends where you are.
Yeah.
Temperate zones. Plant in spring after any danger of frost is gone.
And the tropics.
If it's frost-free year-round, you can basically plant any time. Or if you rely on rain, maybe time it for the start of the rainy season. Depth. Usually around 5 centimeters, maybe 2 inches. But it can be deeper, up to 15 centimeters, even 30 for really big pieces.
Okay, and spacing. You said that was complex.
Yeah, it's a bit of a balancing act. General garden might be, say, 60 to 90 centimeters apart, with rows 1.8 meters apart. Upland systems often use wider spacing, maybe a meter by a meter.
But wetlands are closer.
Much closer, maybe 45 by 45 centimeters. See, closer spacing helps the leaves form a canopy quicker, which shades out weeds early on. That's good.
But the downside?
Too close, and you reduce air circulation. That can encourage pests and diseases, and the corms might end up smaller because of competition. So, yeah, optimizing spacing is key for yield and health.
Tricky balance. What if you don't have a field? Can you do this in pots?
Totally possible. You need big pots, though. Seriously large. At least 50, 60 centimeters deep and wide. Minimum 75 liters, I'd say. And good drainage holes are essential.
1 plant per pot.
Yep, 1 corm per pot, planted about 5 centimeters deep. Works quite well.
All right, so the taro's planted. Now we need to look after it. Ongoing care. Back to water.
Always back to water with taro. Consistent and adequate. About 2.5 centimeters an inch per week is a good rule of thumb. Water deeply when you do water.
And remember, moist, not stagnant.
Exactly. Keep that water moving or draining. Now, nutrients. Taro is hungry.
A voracious feeder, I read.
That's a good way to put it. Yields really respond to good feeding. So add that organic matter before planting, like we said. Then, during the growing season, use a balanced fertilizer.
NPK. Nitrogen, phosphorus, potassium.
Right. Something like a 10-10-10 is pretty standard. Apply it maybe 2 or 3 times, perhaps monthly or every 6 to 8 weeks. Potassium seems especially important for taro corm development.
Granular, liquid, organic, chemical. Any preference?
A mix is often good. Depends on your setup and philosophy. But here's a safety tip.
Let's hear it.
Applying fertilizer to dry soil is a sure way to cause damage. Water first, then feed.
Good practice. Can you overdo it with fertilizer?
Oh, definitely. You might see a white crust on the soil, or the leaf edges look burnt. Sometimes the plant shoots up really fast but looks weak.
And if that happens?
Flush the soil. Water it heavily several times to wash out the excess salts. But honestly, it's usually safer to slightly under-fertilize than over-fertilize. Easier to add more later.
Makes sense. Okay. What about weeds? Sounds like they could be a big problem early on.
Huge problem, especially in those first 3 to 6 months. If you let weeds take over then, you could lose. I mean, sources say 50 to 85% of your yield. It's massive.
Wow. So weeding is critical at the start.
Absolutely. Once the taro plants get bigger, maybe after 6 months, their big leaves create a canopy that naturally suppresses a lot of weeds. But before that, you need to stay on top of it.
Wow. Pulling by hand.
That works, especially for really invasive ones. Early cultivation helps too, but be careful not to dig too deep. Once the taro is established, you don't want to damage the roots.
Mulch.
Mulching is fantastic. Organic mulches, straw, wood chips, whatever you have, they do so much good. Suppress weeds, keep the soil moist, regulate temperature, and add nutrients as they break down. Highly recommend mulching.
Commercial growers might use herbicides, I guess.
Yes, there are specific ones registered for taro, but for home gardens, mulch and manual weeding are usually the way to go. Good field prep helps too, like the sterile seed bed technique.
Okay. And just general watching and waiting.
Pretty much. Keep an eye out for pests, diseases, any signs of stress. Remove any yellowing or damaged leaves promptly helps prevent disease spread. Adjust your watering and feeding based on the weather and how the plants look. Misting helps if it gets really hot and dry.
All right. Fast forward several months. How do you know when it's time to harvest?
Maturity varies a lot by variety, but generally 7 to 12 months. The main sign is the leaves starting to yellow and die back. That tells you the corm is likely ready.
And you need to get them out before frost in cooler places.
Absolutely. Frost can damage the corms, so timing is important in temperate zones.
You actually lift them.
Carefully. Use a digging fork or a shovel, dig around the plant, and gently lift the corms. Try hard not to bruise or cut them.
And remember the gloves.
Yes. Good reminder. Wear gloves when handling the raw plants. The sap can mutate.
Can you harvest just the leaves earlier?
You can, yeah.
Okay.
Once the first true leaf opens, you can start harvesting leaves cut and come again style. Just don't take too many at once. Leave enough for the plant to keep growing strong.
Okay, corms are out of the ground. What next?
Shake off the loose soil. Then there's a process called curing that helps.
Like the drying before planting?
Sort of. You let the harvested corms air dry in a shady, airy spot for maybe 3 days. It helps heal any minor cuts or scrapes, reduces water loss, and makes them less prone to rotting.
Which brings us to storage. You mentioned this is a challenge for taro.
It's a major challenge. This is probably one of the biggest reasons taro isn't a bigger global crop like the potato.
Why? It doesn't store well.
Not really. At room temperature, fresh corms might only last maybe less than a month. They're best eaten pretty fresh.
That really limits things.
It does. It makes transport and large-scale distribution tricky and expensive. Unlike potatoes, which can store for ages under the right conditions.
So how do people store it longer?
Well, if you're in a place with no frost, a common strategy is just leave them in the ground, dig them up as you need them. The soil acts as natural storage.
Smart. But if you've harvested them?
For longer storage, you need cool, humid conditions. Optimal is around 7 to 10 degrees Celsius. That's 45 to 50 Fahrenheit with high humidity, 85–90%, and good air circulation.
How long can they last like that?
Maybe up to 5 months under ideal commercial conditions, but it's sensitive. Go below 7°C and you risk chilling injury. And once you take them out of cold storage, you need to use them within a day or two.
Wow. High maintenance storage.
Definitely. And larger corms tend to store less well than smaller ones. Plus, there are lots of fungal and bacterial rots that can set in during storage.
So that short shelf life really explains why it needs local markets or quick processing.
Or costly cold chain infrastructure. It's a big bottleneck.
Okay, before we move on, that final, absolutely critical safety reminder.
Yes. Cannot stress this enough. Taro corms, leaves, stems must be thoroughly cooked before you eat it. Period. Those calcium oxalate crystals have to be neutralized.
And peeling the corm first is a good idea, too.
Recommended, yeah. Get that rough outer skin off before cooking. Non-negotiable for safety and enjoyment.
All right, let's shift gears now. Beyond growing and eating, taro has this incredible history and cultural weight, more than just food.
Oh, absolutely. It's a genuine agricultural pioneer. This is where it gets really fascinating, I think.
How so?
There's pretty strong evidence suggesting that cultivating taro in flooded fields might actually predate the complex rice paddy systems we see across Asia.
Really? Taro came first?
In key areas, yes. We know taro was domesticated earlier than rice in places like Taiwan, the Philippines, and its ability to grow in waterlogged soil. Well, it likely taught ancient farmers a huge amount.
About managing water.
Yeah.
Preparing flooded fields.
Exactly. The benefits, like higher yields, maybe even natural weed control from the water, they probably figured a lot of that out with taro first. It could have been a crucial stepping stone to rice cultivation techniques.
Wow. A catalyst for agricultural innovation.
It seems very likely.
Yeah.
And it didn't stay put. It became a voyager's companion.
Spreading across the Pacific.
Right. Austronesian peoples, the great navigators, carried taro eastward into the Pacific Islands starting around 1300 BC. It became absolutely fundamental there. Preferred, often, because Colocasia esculenta is less irritating than some other things also called taro. We find traces at ancient Lapita archaeological sites.
And it went west, too.
It did. Reached Egypt, the Mediterranean, China, Africa, Madagascar by the 1st century AD. Its history traces human movement, survival.
And darker chapters, too, I read.
Unfortunately, yes. It was used as provisions on slave ships traveling from West Africa to the Americas in the 18th century, a grim part of its global journey.
So if it spread so far, why wasn't it adopted everywhere? You mentioned climate.
Climate was a big factor. Europeans, for instance, didn't really adopt it. Their climate wasn't suitable, and the corms didn't travel well over long sea voyages back then. And even where it was introduced, it sometimes faced limits.
Like in New Zealand.
Exactly. Polynesians brought it there, but the cooler, temperate climate wasn't ideal. Taro struggled. Eventually, sweet potato, which was better adapted, largely replaced it as the main staple. It shows how culture and ecology interact. What works in one place might not work in another.
That adaptation piece is key. Speaking of which, ancient Hawaiians, they really took taro cultivation to another level, didn't they? Kalo, they call it.
They were incredibly sophisticated horticulturalists. Their wetland terrace systems, the luai, just genius.
Tell us about the luai.
Okay, so imagine terraced ponds fed by gravity using diverted stream water. They built walls with loose rocks, not sealed tight. Why? To keep the water constantly, gently circulating.
Avoiding that stagnant water problem.
Precisely. They controlled the flow rate very carefully, kept the water cool, oxygenated, brought in nutrients, washed away waste, prevented the corms rotting, kept them perfectly hydrated. It was complex hydraulic engineering, really.
And incredibly productive, you said.
Massively productive. 1 acre could yield maybe 3 to 5 tons a year. That's like 10, maybe 15 times more than growing it in dry land conditions.
Wow. And sustainable, too.
Very. They'd harvest the main corm, then replant the top part, the huli. That would grow new baby plants, keiki, around it, forming an ohana, a family. It allowed continuous harvests for generations from the same patch.
Ohana means family, right? So the word for family comes from the taro plant itself.
It does. Ohana is the taro corm, or shoot, and ohana derives from that. It shows just how central kalo was, not just to diet, but to the entire concept of family, community, interconnectedness.
And there's a sacred connection, too, the Haloa myth.
Yes, a very profound creation story. The firstborn son of the sky father and earth mother was stillborn, and from his body grew the first kalo plant, named Haloanaka. Their second son, who lived, was named Haloa, and from him descended all humans.
So humans are genealogically related to taro, but junior to it.
In that worldview, yes. Kalo is the elder sibling. This creates a sacred duty, a covenant. Humans must malama care for, cherish, respect Kalo. And in return, Kalo sustains humanity. It's a powerful framework for relating to the natural world.
And that ancient reverence, it connects to things happening now.
Absolutely. You see Hawaiian activists drawing directly on this, for instance, in debates about GMO Kalo. It's about cultural sovereignty, indigenous rights, protecting their ancestor. The connection is deep and living.
It's not just Hawaii either, right?
Yeah.
Significant elsewhere in the Pacific.
Definitely. Features in folklore, traditions across the Pacific. You even see it on money in Samoa and Tonga, often used as a prestige food for feasts or gifts.
That zero waste idea comes back too, with non-food uses.
Right. Medicinal potential is being explored. Compounds that might fight cancer, inflammation, boost immunity. Industrially, the stems were used for dyes. The starchy poi could be used as glue. The starch itself has potential in pharmaceuticals as a filler or binder in pills. And spiritually, specific varieties were used as offerings.
So taking all this in ancient, nutritious, versatile, culturally vital, it really highlights that paradox again. Why is it still underutilized and undervalued?
It's baffling in a way, isn't it? All this history, all these uses, yet compared to potatoes or rice, it's a minor player globally. It suggests there's this huge hidden value, untapped potential, a real opportunity perhaps.
Okay, let's zoom in on one specific region now, Australia, because the story there adds another layer of complexity. Taro as an environmental weed.
Yeah, this is where it gets complicated. In parts of Australia, especially Queensland, Colocasia esculenta is actually considered a significant environmental weed.
How does a food crop become a weed?
Often escapes from gardens. People plant the ornamental varieties, those elephant ears, and they get into waterways, creeks, wetlands. They grow fast, form dense stands, and push out native plants.
And they spread easily.
Very easily. Both by seed birds or floodwaters can carry them, and vegetatively. Bits of rhizome or corm break off and start new plants. Some ornamental types, especially the purple-stalked ones, are particularly bad offenders.
So what do people do about it?
Control is difficult. Pulling them out manually is often the most effective, but labor-intensive. Herbicides are used sometimes. Cutting them back doesn't really work, they just regrow. It creates this direct conflict, right? Valuable food source versus invasive plant.
So if you want to grow taro there, you have to be careful.
Extremely careful. Growers have a real responsibility. Choose the right varieties. Edible ones like bunlong or Chinese are thought to be less invasive in southeast Queensland.
Containment too.
Definitely. Growing in large contained pots or properly constructed raised beds is recommended. And being super careful about disposing of any plant waste, don't just dump it where it can spread. It's also important people know the difference between the edible Colocasia and the purely ornamental Alocasia, or giant taro, which isn't usually eaten and can also be invasive.
And it's not all negative. There's research happening.
Yes, thankfully.
Yeah.
The University of Queensland, for example, has been looking at wild Aussie taro relatives, screening them for things like salt tolerance, using DNA fingerprinting to potentially breed more resilient, climate-adapted taro.
That genetic diversity sounds crucial.
It's vital, especially after seeing disasters like the Taro Leaf Blight that wiped out crops in Samoa in the 90s. Having diverse genes is insurance against future threats.
And for someone actually growing taro in Queensland?
The climate, especially subtropical Queensland, is pretty much ideal. Year-round planting is possible in the tropical north. There are challenges: sure pests, fungal diseases, love the humidity, it takes a while to mature, but the potential is there.
Any specific regulations?
Well, it's not officially restricted, but because it's a declared environmental weed, the general biosecurity obligation applies. Basically, you have a duty of care to prevent it escaping and causing harm. Responsible cultivation is the bottom line.
Okay. So, wrapping up this deep dive, we've covered a lot of ground, from taro's incredibly ancient roots
Through its role as an agricultural game changer, a cultural touchstone,
to its modern potential and also the challenges, like storage and invasiveness.
it really is an unsung hero in many ways. So resilient, so adaptable, and the human ingenuity it inspired, like those Hawaiian laiwi systems, just incredible.
And looking forward, despite the hurdles, it feels like it has so much to offer, doesn't it? Food security, nutrition, health, sustainable farming.
Absolutely. Its story isn't just history, it feels relevant today. It's this living link to human innovation, cultural depth, and maybe a reminder that ancient wisdom can hold surprising answers for our future.
Leaves you wondering, doesn't it? What other underutilized heroes might be out there hiding in plain sight, just waiting for their own deep dive?
Makes you think. Maybe take a look around your own region, your own interests. What overlooked plants or resources might hold that kind of untapped potential? Food for thought.